Hello there, welcome to the October 2020 ASFM maths test. Here we're on question 10, the final question for this paper. So given that there are two distinct complex numbers, the z, that satisfy both of these set notation locus points here, determine the exact range of values for the real constant r. So r is in here, that's going to determine the radius of the circle. Let's just draw a really clear diagram so we know and can visualize what we're doing here. So we have the circle that has a center at 3 across, 5 up. So that's going to be approximately here, 3, 5. And it's going to have a certain radius. We're not quite sure what that radius is yet. And then we have this on the right hand side, which is arg of 2. So that's going to start arg z minus 2. So that will start at 2. And if it has a argument of 3 pi by 4, then it's going to go exactly in the upward left diagonal by a gradient of minus 1 effectively. So you could say that this is the equation y equals minus x plus 2, because if it's an exact diagonal, then this point here will be 2, given that it's this point here 2 as well, and it's an exact diagonal, so therefore it has a gradient of minus 2. So if it was the so we want to know if it has exactly 2 intercepts, what is the values of r. So if I go too big in my radius, then it's going to miss out on the second intersection point coming down to the right. But if I'm too small, then it's going to miss all of them as well. So for the biggest one, so for the smallest radius value, it's going to look a little bit like that, where it's just one intersection here. And then if I do the biggest one, it will have to intercept at 2 there. So it's going to look a little bit like that. So this one here has the largest value of r, and this one has the smallest value of r. So then that would just be my limits for the radius. Let's work out for the smallest value of r first. Then it's going to be at this, then if it's the smallest value of r, then this line of y equals minus x plus 2 is going to be a tangent to this circle here. And if it's a tangent, then the gradients will meet at a right angle. So this line here is going to be the equation y equals x plus something, because it's going to have perpendicular gradient to minus x, so it's therefore going to be x. And if we put in y equals, so x equals 3, y equals 5, then the plus c is going to have to be plus 2. So actually, this coordinate here of 2, it is going to be the intersection exactly. So it's going to be intersecting at the coordinate 0, 2. So therefore the radius is going to be, okay, so let's work out the radius here. The radius is going to equal, so if that's 0.02, then it's going to be 3 to the right and 3 down, so that's going to be 3 squared plus 3 squared, which is 3 root 2. So the smallest value for the radius is 3 root 2. So the smallest value for the radius is 3 root 2. But actually the radius here is 2r, so therefore, so this we could say here is the radius has to equal 3 root 2, so therefore r is going to be 3 root 2 over 2, because for some reason on the end here it says it's equal to 2r. For the biggest value of the radius is going to be the direction between the centre point 3,5 and the point 2, 0. So for the biggest value of the radius, it's going to be the square root of, so it's going to be 1 across and 5 up to get to that one. So 1 squared plus 5 squared. So therefore the radius is going to be the square root of 26. Root 26. So therefore r is going to be root 26 over 2. Because the radius in this question here is apparently 2r. So therefore the value for r is going to be in between not equal to on any of these points here, because if it were equal to on the smallest one, it would just have one intersection point, and if it were equal to, actually it could be equal to it on the bottom one, sorry, on the top one, because it will have two intersections there. So on the top one, it's going to be root 26 over 2. That would be the largest value the value of r could be, and the smallest value of the r could be is 3 root 2 over 2. Because then it would only have one intersection. So there we are, that's the answer for this question here. Quite a tough one there. It's the diagram that was the key to this question here, visualizing the question with the use of a diagram, thinking about when it will have one intersection, 0 intersections, or 2 intersections. So there we are, that's the answer for question 10 there, that's 7 marks, and that's the answer, all the answers to October 2020 AS Further Maths core paper. Hopefully you found this set of videos helpful to go through the answers, and hopefully there'll be more in 2021. Thanks very much for watching.